So this indicates when you're solving any linear programming problem, my solution will exactly lies on the first quadrant of a coordinate axis. X and y as 0, again you will get 0 less than or equal to 10. That means 0 lies in the solution region of these inequality. Here also you will get x and y 0, 0 greater than 2, which is false. So that means your solution region lies where 0 is not there. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we are going to revise the chapter Linear Programming Problem. So from this chapter, you will get 4-mark question as well as 5-mark question. So which is an optional. If you get 4 marks, you will not get 5 marks, or if you get 5 marks, you will not get for 4 marks. So 4 marks problem is basically on formation of LPP, but 5-mark question is basically to solve the linear programming problem. So therefore here under part D, which is a 5-mark question, you might get 1 question, or from part E you will get a 4-mark question. So therefore maximum you will get 4 or 5 from this chapter. So as I said, let's see how to formulate LPP, then we will solve LPP. Now the statements will be given to formulate LPP here. So one question is given here. A company produces 2 products P and Q. Each P requires 4 hours of grinding and 2 hours of polishing. Each Q requires 2 hours of grinding and 5 hours of polishing. The total available hours for grinding are 20. For polishing is 24. Profit per unit of P is 6 and Q is 8. Formulate the LPP. So first let us write the data. So we have here 2 products here. So let us write the data in a tabular form. So we have product P as well as product Q. Next we have the first process is here grinding, and the second process is polishing. So product P takes 4 hours of grinding and 2 hours of polishing, whereas product Q takes 2 hours of grinding and 5 hours of polishing. But the total available hour for grinding, so availability for both. So availability for polishing as well as grinding is 20 and 24. And next, the cost of product P per 1 unit, cost of product Q per 1 unit is given. So that is cost of P is rupees 6 and cost of product Q is rupees 8. Now we need to formulate the given LPP. So let me take the number of product produced, that P is X and products Q be Y. Then from this equation you can see for grinding, P takes 4 hours, Q take 2 hours. So the maximum availability is 20. So the number of product produced in terms of grinding, so is given by 4x plus 2y less than or equal to 20, because the maximum availability of hours is 20 itself. So therefore the hours of finishing must be less than or equal to 20. And now for polishing, here we have 2 times x plus 5 times y less than or equal to 20. So then what is the cost? So the cost is that with the minimum cost, we need a maximum profit. So therefore, with the minimum requirements, we need to find the cost so that we will get a maximum profit. So therefore, my objective function will be z is equal to 6x plus 8y. So writing all these in a particular form, first we need to find out the z. So here we are finding the profit. So therefore we need to maximize the objective function. So that's why here the given data can be written as maximize z is equal to 6x plus 8y subject to constraint 4x plus 2y less than or equal to 20, 2x plus 5y less than or equal to 24, where both x and y are greater than 0. Since it gives you the number of products of P and Q, obviously it has to be greater than 0. So this indicates when you're solving any linear programming problem, my solution will exactly lies on the first quadrant of a coordinate axis. So this is the answer for the given requirement. Next. Prateek wants to decide the constituents of diet which will fulfill his daily requirements of protein, fats and carbohydrates at minimum cost. The combination is made among two products A and B whose contents are indicated below. So this is proteins, fats and carbohydrates, and these are the product A, product B, and the minimum requirement is given. So minimum means he needs 800 milligrams of protein, so he can get more than 800 also using product C and product B. So how to formulate here? So minimum requirement of proteins is 5 times A, 2 times B, and it is 800. Fat is 6 times A, 5 times B, 200. Carbohydrates is 4 times A, 3 times B, 700. And the cost per unit of product A is given, that is 70, and B is given 30. So with the minimum cost, he need to get all this protein, fats and carbohydrates. Now how to formulate LPP? Since my aim is to find the minimum cost with product A and product B, so rupees 70 for A, rupees 30 for B. So let me take X as the number of products A, Y as the number of products B. So therefore my LPP is minimize Z is equal to 70X plus 30Y, because I need to find the minimum cost. Now subject to constraints. Subject to constraints. So what are my requirements in terms of protein, fats and carbohydrates? That is 5x plus 2y greater than or equal to 800. So the minimum is 800, so he can get more than that also. So therefore I need to put greater than or equal to. Next, 6x plus 5y greater than or equal to 200. That is the equation formed using fats, product A and product B. Next, for carbohydrates, 4x plus 3y greater than or equal to 700. And obviously x and y should be greater than or equal to 0. So this is the formulation. Next question. So I told you 4 marks problem is basically to formulate an LPP and 5 marks will be given to solve a LPP. So let us take one maximize problem and one minimize problem. Now given here maximize Z is equal to 5x plus 3y subject to the constraint 3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10, x greater than 0, y greater than 0. So let us solve the linear equations, that is linear inequalities given, and let us draw a line on the first quadrant of a coordinate axis. So first let us solve 3x plus 5y. Instead of less than or equal to, I'll take 15 is equal to 15. So let me find the coordinates in terms of x and y. If x is 0, y is 3. If y is 0, x is 5. So therefore the coordinates are 0, 3 and 5, 0. Next, for the second set of equation, 5x plus 2y is equal to 10. So let us find the coordinates x and y. If x is 0, y is 5. If y is 0, x is 2. So therefore the points are 0, 5 and 2, 0. So let us plot this using a graph. So let me draw a graph. So origin, so let me consider it as 1, 2, 3, 4, 5, 6, 7. This is your x-axis. So 1, 2, 3, 4, 5, 6. This is your y-axis. Always remember, use 1 centimeter to draw the units here. So my first equation is 3x plus 5y is equal to 15. The coordinates are 0, 3, 5, 0. So let us draw a straight line joining these 2 points. Once you have written this line, write the equation of line 3x plus 5y is equal to 15. Now for the second one, my coordinates are 0, 5, 2, 0. So write the equation of the line 5x plus 2y is equal to 10. So that means my solution for both the lines lies below the lines. So that means the solution containing origin will satisfy the given condition. Suppose if you put both as 0, you will get 0 less than or equal to 15. X and Y as 0, again you will get 0 less than or equal to 10. That means 0 lies in the solution region of these inequality. So that's why, so here this will form a common solution region for both the lines. So once you get the solution region here, you are supposed to mark the corner points. So what are the corner points here? Now let me write the corner points. This as origin O, this as A, this as B, and this is C. A is already we know, that is 2, 0. C is already known, that is 0, 3. B we need to find out. So from your graph, when you see the nearer value, suppose it, so your X value lies here, so that is here somewhere, and your Y value is here somewhere. So this will give you the intersection of X and Y here. So now once you find the corner points, let us write this in a corner point table. So that is, you have corner points here and your objective function, that is Z is equal to 5x plus 3y. Now let's write the corner points. 0, 0. A is 2, 0. So B is almost, it will be equal to 1.05 to 2.36 approximately. So here next C is given as 0, 3. Now substitute the value of X as 0, Y as 0, X as 2, Y as 0, X 1.05, Y 2.36, C 0, Y 3. So on solving this, so for the first one, we will get the value as 0. For the second one, we will get it as 10. So approximately the value is equal to 12.33, and here you will get the 9. So you can observe that the maximum value is at the point 1.05, 2.36. So therefore, Z max is equal to 12.33 at B. So this is the solution for the given LPP. Next one is minimize Z is equal to 3x plus 5y subject to constraint x plus 3y greater than or equal to 3, x plus y greater than or equal to 2, x plus y greater than or equal to 0. So this always indicates the solution lies in the first quadrant. Let us solve for the given equation. X plus 3y is equal to 3. So when I write the coordinates here, x and y, when x is 0, y is 1. When y is 0, x is 3. So therefore the coordinates are 0, 1 and 3, 0. Next equation is x plus y is equal to 2. So very simple to write here. X, y, 0, 2, 2, 0. So therefore the coordinates are 0, 2 and 2, 0. So let us draw the graph for this. So we have x-axis as well as y-axis. This is origin 1, 2, 3, 4. 1, 2, 3, 4. So my first coordinates are 0, 1, 3, 0. Join the line. So what is the equation? X plus 3y is equal to 3. My second coordinate is 0, 2, 2, 0. Join the line again. So the equation is x plus y is equal to 2. So if you take x and y as 0 here, you will get 0 greater than or equal to 3, which is false. Here also you will get x and y 0, 0 greater than 2, which is false. So that means your solution region lies where 0 is not there. So that means when you observe the graph here, solution 0 is here. So if you shade any region below the line, obviously it contains the point 0. So you need to shade the region where you do not have point 0. So obviously my solution region will be the region above these two lines, which doesn't have 0 as the solution region. So clearly you can observe this shaded region will give you the solution region. So now let us mark the corner points once again. So that is, you already know this corner point, this and this. So from the graph, you can get this point. So let me take this point as A, this as B, and this as C. So we have point A, B, C. So let's write the corner points. And my objective function is z is equal to 3x plus 5y. So therefore here, so the first point is 3, 0, that is A 3, 0. B you will get it when you observe the graph here. So you can clearly see. So you can take B as 1.5, 0.5. Next, C is the point 0, 2. So when you substitute here, the first point you will get the value as 9. When you put 3 into 1.5 plus 5 into 0.5 and add it, you will get the value as 7. For the third one, you will get the value as 10. Now among this, which is the minimum value? 7 is the minimum value. So therefore, Z minimum is equal to 7 at B. So at the point B. So this is the minimum value for the given linear programming problem. So thus we have found how to formulate the LPP and how to maximize and minimize the LPP and finding the solution, that is finding the maximum value or minimum value at particular point. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.